Hi friends, today we will see source free RL circuit. Okay, that means only resistance and uh, inductance are present. There is no source. Source free means there is no source. Okay, that means initially inductor is charged, it has some energy. So now that energy is dissipated through this resistor. So it has some energy initially, therefore the initial current I of t, okay, there is some initial current. So I of t is equal to I naught at t is equal to 0. That means initial current is I naught. And this is R, this is L, okay. So V of t and VL, so current is flowing like this, so plus minus. And here the current is flowing in this direction, so it is plus minus here, okay. Now by applying KVL, okay, now by applying KVL, so let us write like this, okay. So the voltage across this VL, that means L di by dt. So I is the function of time, okay. L di by dt plus Ri is equal to 0, okay. Now, so L di is equal to minus Ri dt, okay. So I is here, so let us bring I here. 1 by I di is equal to minus R by L into dt. So now let us integrate, okay. So 1 by I di integration, so that becomes log I is equal to, so this will be minus R by L into t plus C. Understand? Now at t is equal to 0, so I of t is equal to I naught. Understand? That is initial condition. So now substitute t is equal to 0. So here it will be 0. Okay, here it will be 0. That means 0 plus c. So this will be log. This is I of t. Understand? That means that will become I naught. So now c is equal to log I naught. So now substitute this initial condition in this equation. Okay, now log I of t is equal to minus R by L into t plus log I naught. Now bring this to the left side. Log I of t minus log I naught is equal to minus R by L into t. So this is log A minus log B becomes log A by B. Understand? Okay, this is log A minus log B is equal to log A by B. So that is equal to log of I of t by I naught is equal to minus R by L into t. So this implies E I of t by I naught, okay, I of t by I naught is equal to e power minus R by L into t. Understand? That means I of t is equal to I naught into e power minus R by L into t. Understand? Now this is a current in that circuit. Now let us draw the graph between t and I of t. So at t is equal to 0, okay, t is equal to 0, I of t is equal to I naught. So this is 0, e power 0 is 1, so I of t is equal to I naught. And yet t is equal to infinity, so I of t is equal to I naught into e power minus infinity, that is equal to I naught into 1 by e power infinity, that is I naught by infinity, that is equal to 0. Understand? So that means the graph will be like this. So this is I of t and this is t. So t is equal to 0, it will be I naught here. This is 0. And at t is equal to infinity, okay, so it will be I of t will be 0. That means it will decay like this to infinity. Understand? So the curve may decay in two different ways, okay. So I will show here. So it may decay very fast or it may decay very slow. Okay, so this is called slow decay and this is called fast decay. So this slow decay or fast decay depends on the values of R and L. Okay, depends on the values of R and L. Okay, now let me consider we have that formula I of t is equal to I naught into e power minus r by l into t. Okay, so now I will write I of t by I naught is equal to e power minus r by l into t. Understand? So now I will draw the graph between t and this I of t by I naught. Understand? Now if t is equal to 0, this value becomes 1. Understand? This value becomes 1 and it will come to 0. Understand? At t is equal to infinity. Now from this I want to define one thing, that is time constant. Time constant. So it is the time required to reach the curve to 0 when it falls at initial rate. Understand? So it is the time required for the curve to reach 0 when it falls at initial rate. So initially it is falling at this rate. You see here, initially it is falling at this rate. So it has to fall the same rate. Okay, so then this will become the time constant. So time constant is represented like this. So it is the time required for the curve to reach 0 when it falls at its initial rate. Understand? Okay, so now this is the time constant. Okay, now let us calculate the slope. Okay, because it is falling at the same rate. Okay, so slope is equal to for any curve it will be derivative of that curve. Okay, e power minus r by l into t. Okay, so that will become, so e power minus r by l into t and minus r by l will come here. Understand? Now initial slope. Okay, so initial slope, that means at t is equal to 0. Okay, so put t is equal to 0 here, so it will be 1. So minus r by l is the initial slope, initial rate. Understand? At t is equal to 0, so minus r by l is the initial slope. Okay, so if the curve falls at this rate, then it reaches 0 at this time. Okay, so that is called the time constant. Okay, now this is x-axis, right? So it will be t comma 0, t comma 0, and this is y-axis, that means 0 comma 1. Okay, so this is a straight line. Understand? So now for this straight line, what is the slope of the straight line? y2 minus y1 by x2 minus x1, that means 0 minus 1 by t minus 0. So that is the slope of this line, and we have find the initial slope. Okay, so initially at t is equal to 0, the curve is falling at this rate, that means minus r by l. Is it clear? So minus 1 by tau is equal to minus r by l, so tau is equal to l by r. Understand? So this is the time constant. Okay, so time constant, the units are seconds, so tau is equal to l by r seconds. Now at t is equal to capital T, I of t is equal to I naught into, okay, so here we have to substitute, okay, in this equation. Okay, so I of t is equal to I naught into, here in place of t you have to put capital T, that means L by R. Understand? So then you will get I naught into, so 0.368. Okay, so at t is equal to 2t, so I of t is equal to I naught into 0.135, and at t is equal to 3t you will get I of t is equal to I naught into 0.049, and at t is equal to 4t, I of t is equal to, you will get I naught into 0.018, and at t is equal to 5t. Okay, 5 time constants. Understand? I of t is equal to I naught into 0.0067. That means if you observe, okay, So this is t. Okay, now initially, so this is I of t. Initially this is I naught. Okay, this is 1 time constant, 2t. This is 3 time constant, this is 4 time constant, this is 5 time constants. So for 1 time constant, okay, so it will come up to 0.368 of I naught. So this is total I naught. So let it be the 0.368 of I naught. So for 1 time constant, it will come till here. And for 2 time constants, 0.135. So 0.135 of I naught. So it will come till here. Okay. So similarly, it will come like this, So finally, for time constant, 5 time constants, it will come 0.0067. Okay. So this is the curve. Okay. Now L by R is the time constant. If time constant increases, okay, that means t is moving in this direction. That means it is falling at a slow rate. That means that is called slow decay. Understand? If L by R is more, that means time constant is more, then it is called slow decay. If L by R is less, then it falls very fast, that means fast decay. Okay, thank you.